Okay, so when you go to the practice, or if you're looking over all 4 of those activities later, it's I think interesting and helpful to realize how it all relates back to transformations. This is the cool idea about all this. And I'm not sure that making that connection, in some cases it will directly help you with the homework because some of the homework asks about it, but I think that making these connections on a deeper level, even if it doesn't seem like it's useful to you to get through the homework, I think it really helps build a bigger picture in your mind of what exactly is going on with all of this stuff. So keep that in mind. For example, here is one of my acute angles in right triangles, and cosine of pi by 2 minus theta is the same as cos bracket. If I factor out the negative, bracket theta minus pi by 2, which may have been one of your other guys down here. It wasn't one of mine, but it could have been one of your horizontal translations between sine and cos down there. Okay? It kind of is one of mine, but not quite. So it's interesting how we're writing this in terms of acute angles, but you can like factor it and write it in the correct form for a transformation for a graph, and it still obviously works. But like in our heads, we think graphs are different from SOHCAHTOA. We think the periodic graph of sine is different from SOHCAHTOA somehow, and it's not really different. It's a different way of representing the same concept. Okay, so the idea here is that if I'm taking sine of theta, what is sine of theta? It's let's say this is A over B, opposite over adjacent, opposite over hypotenuse, A over B. And cosine of this angle, which is pi by 2 minus theta. So if that was my example before, if this is 30, this is 90 minus 30, which is 60, is still A over B, right? It's the same. What does that mean? It means they're equal. They're equivalent expressions. That means if you take the sine of any value, it'll give you the same answer as taking the cosine of pi by 2 minus that same value. In radians or degrees, but we're working in radians. Does that make sense? So once that clicks, it's an easy idea. And this is something you do in grade 10, where or you should have maybe talked about, where I could solve any problem with sine, right? Opposite over hypotenuse. But if I wanted to, I could find this angle and then use cosine is adjacent over hypotenuse. It's the same thing. They'll both solve that problem. Okay, so that's all that the acute angles. That was activity number 3. That's what it's talking about. So that's true for cosine the same way. And cotangent and tangent is opposite over adjacent or adjacent over opposite for cotangent. So it's the same relationship. What about the first one, horizontal translations? Sine to sine, you could just add a period. So you could always add 2 pi. Right? Or 4 pi, or 6 pi, or 8 pi. And you get an equivalent expression, sine of theta equals sine theta plus 2 pi. Or you could flip it and do it that way, right? Or you could flip it the other way and translate it, change the phase shift, give it a phase shift, and that would have lots of different answers for this, no one answer. That's why I thought it was a better idea to kind of think it through. You could build your own huge list of all. I wouldn't do multiple periods, right? Like 2 pi, 4 pi, 6 pi. But I mean, like with all different kinds of reflections in the y-axis, in the x-axis. Spend a moment thinking about it. This is why technology is great, because you can really quickly graph them all and see for sure if it's true, right? So like in GeoGebra, tan of negative x equals negative tan of x. There you go, right? I just showed it by graphing. They're on top of each other. And I could change the period, change the reflection really quickly in here, and show all different kinds of connections. That was the odd-even symmetry. So if you remember odd-even symmetry, it has to do with rotational symmetry about the origin. That's when it's odd, like a cubic function. So tan is that way and sine is that way. And that means that the sine of negative x equals negative sine of x, or sine of negative theta equals negative sine of theta. If you look back at our notes from way at the beginning of the course, that's the same idea. F at negative x equals negative f at x. It's the same idea. Whereas cosine is even. It has symmetry about the y-axis. And so like it flips onto itself like a parabola, right, about the y-axis. So cosine negative theta equals cosine theta. And again, this is like true for values of theta. If you put values of theta in, you'll get that. But it's also true in terms of transformations if you think about it. Right? And then, did we miss one? No, that was the third one already? Yeah, okay, good. And then the last one, principal and related angles on page 392. That's right before, or that's right where the work starts. All the formulas are listed there. I want to get to a couple of examples. All the formulas are listed there, so you can write them down, copy them from there. These guys are there as well. Okay. This we've already done. It's just that idea that if once I find the related angle, or let's say I have the principal angle, the related angle here is just pi minus, right? Or if I have the related angle here, it's pi plus, or if I have it here, it's 2 pi minus. Okay, that's all that is. And again, you can show how this is, you can show these properties with transformations or with all kinds of different ways of doing it. Okay, so don't pack up, because before we do that, I want to show you exactly how this works. You don't have to write this down if you don't have the chance, because I'll post it. But write an expression. This is a tricky part, so we're just rushing this. But write an expression equivalent to each of the following: cos of pi by 8. So if I want to use, let's say I want to use, often we're going to use these guys. Cos of pi by 8, so that's here. Cos of theta is equal to sine of pi over 2 minus theta. So it's equal to sine of pi over 2 minus pi over 8. That's my theta. Pi over 8 is my theta. And then you would work that out with fraction math. Okay, so same thing, an equivalent expression. There could be others. You could have used something else. This isn't very specific. It doesn't say use sine. So you could have done like cos of pi by 8 plus 2 pi. Like you could have just added a period and it would be equivalent. So if you do something different, your answer might not match the back of the textbook. You could use your calculator to check and make sure they're exact. Shouldn't be exact but negative. Should be exact. Okay, that's what an equivalent expression is. You type both in your calculator, you get the exact same answer. Not one's negative, one's positive, nothing like that. So tan of pi by 3, how would I do that? I could use this one, cotangent. So it equals cotangent of pi by 2 minus pi by 3. And then again, work that out to exactly what that is. One last example, use transformation. So I think you've already done this, so I don't think it's a big deal that this is getting rushed. Use transformation to explain the following. I think there's something missing there. So sine, oh no, that should be fine. So here's what I would do. I would say on the left side, I'm going to factor this. Sine bracket, factor out a negative. So it would be negative theta plus pi, which is sine bracket, negative bracket, theta minus pi. Graph those. Think about what this does. Reflects in the y-axis. Think about what this does. It's a shift one way by half a period. So it wouldn't matter if it's plus pi or minus pi in this case. Show that those are the same. That's the same as the original sine graph. Nope. Right? And then continuing on the other way. And that's it. There's your work.